So let's start by, what if I gave you, and I drew for you, let's say this line right here, okay? How could you get, what would the equation of that line be that I just drew out of there? What would it be? Yeah, very good. X is equal to -3. Okay, that's pretty straightforward. We all know that one. No big deal. Okay, now let's say that I draw that same line at x equals -3, but then all of a sudden I shade to the right. Okay? All of a sudden I've changed my graph from an equation to an inequality. So how could I represent that inequality? X would be greater than or equal to -3, right? X would be greater than or equal to -3. So I've changed it, right? All right, so that's all review. Is that true? Review? Okay, what if I get this line here? What would this one be? That'd be the line y equals 3, but then what happens if I shade it down then over here?
Y is less than or equal to 3.
Yeah, so let me move this up so everybody can see. So this would be y would be less than or equal to -3. Now, how do you know that you shade, or how do you know that it's less than there in this particular case? Anybody know why it's less than? Well, let's say, for an example, what if I took a point over here? This point's called the origin, right? This is the point, and that's the point 0, 0. So that's x and then y. So if I were to test this against my inequality, I would have 0 is less than or equal to, this should be +3, huh? 0 is less than or equal to a +3. So is that a true statement or a negative statement that there? Is 0 less than 3, you guys? True or false?
True.
That's totally true, right? So we're looking for true statements when we take a test point to shade our inequalities, right? And here's my last one for you. What if I gave you this line right here? What's the difference between this one and the one I did before?
It's dotted.
It's dotted, right?
It's
not equal.
Yeah, it's going to be not equal to, right? So what if I then shade above this line here? Could you guys write the inequality that represents this? Y would be strictly greater than +2, right? Okay, so we're doing a little review here of inequalities, right? So if I don't shade, then I have an equation. I had x equals -3. If I shade to the right, x was greater than or equal to -3. If I move up here, and then I have y was less than or equal to 3, go ahead. And then y was greater than 2. All right, we want to graph the inequality y is greater than or equal to x squared minus 1. So first thing we're going to do is we're going to give ourselves a coordinate plane. So go ahead and give yourselves a coordinate plane here. And what is this a graph of, you guys? Is this a line? It's a parabola, very good. And where has that parabola been shifted? It's been vertically shifted
Down.
1 unit down, right? Okay, good. So we're going to go 1 unit down. We're going to put an anchor point there. I'm going to put in my other anchor points. And you'll recall for y equals x squared, wherever the vertex is. In this case, my vertex is down here at -1. It goes to the right 1 and up 1, and to the right 2 and up 4. 1, 2, 3, 4. So there's another anchor point. And then left 2, up 1, 2, 3, 4. Okay, there we go. Easy enough. Now, am I going to draw a solid line or am I going to draw a dashed line? I'm going to draw a solid line. How do I know that?
Greater than or equal to.
Because it says greater than or equal to, right? Because of this part right here. This little part that I'm pointing to right there implies that I'm going to have a solid line, which we all kind of know anyways. So now what we're going to do, so the first thing that we did was we graphed it, huh? So I'm going to just kind of keep track of what we're doing. So the first thing we did was we did a graph. Okay, then since I don't have a line anymore, I have a parabola, I'm actually going to take a test point. And the easiest test point to test is the origin. And we're going to test 0, 0. So I'm going to go ahead and test 0, 0 into my inequality and see what kind of statement I get. So I would get 0 is greater than or equal to 0 squared minus 1. So 0 is greater than or equal to -1. Is that a positive statement? I mean, is that a true statement or a false statement? That's a true statement, right? Okay, so if I have a true statement, then I'm going to shade in the direction of my true statement, and I'll be shading everything inside of my parabola right here. Nice job, Meghna. Way to go. So the second thing that we did was we took a test point, right? And then finally, the third thing we did, we shaded the true region. Shade the true region. So everything that we have in here is our region. So go ahead in your table groups, graph x minus y is strictly less than 2. And then take your calculators out because I'm going to show you how to do something on your calculator. Okay, so how many people were able to realize that, okay, you had to, I kind of got this into y equals form, so I got y is greater than and x minus 2. Was that easy enough for you to do? Okay, and then if you take a look at the picture here, right, then you should have something that looks kind of like this, where you'd go down 2, and then the slope would be up 1 over 1, and you have a dashed line, and it should be pretty straightforward. And then the one we had before was sort of this parabola here. So what I want to do now is I'm going to shrink this down, and then I'm going to show you how to graph these actually on your graphing calculator. So we're going to set our calculators out, turn this on over here. Whoops, can I grab this here and do this? All right, so go to the y equals for me. And then what we're going to do is we're going to punch in y equals x squared and then minus 1. Now notice on our calculator we don't have an equality symbol, so we have to treat it like an equation. So we're going to punch in y equals x squared and then a minus 1. Okay? So there's x squared minus 1. And then if we hit graph, and then we would all see just the parabola that we have kind of graphed there. Now we can't really make our lines anything dashed or undashed, but what we can do is it can actually create regions, and here's how you do it. So if you go to the left of your calculator, of the calculator y sub 1 button, if you go all the way to the left, see how mine's blinking over here now? Right? So if you push the enter button one time, notice it changes to a darker line. Did you see that? So you know what that does? That makes your graph darker. Look, just like that, which is kind of cool, right?
Mine did that.
Well, then if you go back, okay.
And this comes up when I click on it.
Yeah, so that's a different screen, so see if you can follow through that screen what that's saying to do, okay? So for those of us that have the TI-83s, okay, if you push enter again, you get an upward triangle, okay? So the upper triangle then can actually stand for greater than in this case. So look what happens when you hit a graph now. You can actually shade that region in your calculator. It's pretty sweet, all right? Now, if you go back and you actually would push less than, if you push enter one more time, you get a lower bound triangle. And then if you push graph, you get, check it out, you get everything below that. All right? So here's what I want you to do. I would like you guys to graph on your calculator, graph box number 3 right now. And I'll help people out, okay? All right, so now what we're going to do is, now that we've learned how to graph these on our calculator and graph these systems, what we're going to do now is we're going to actually make a system, right? We were just graphing singular inequalities. Now we're going to actually make a system of inequalities here, and we're going to see what happens when we try to put all these together, all right? So from the x minus y is less than 2, we just graphed that one, and we saw when we changed this into y equals form, we saw this was y is greater than x minus 2. And then these are already set, so here's what we're going to do. So we're going to make a nice little graph for ourselves. Oh, wow, that's actually pretty straight. So here's my x coordinate here and my y, x and y axes. So we're going to go ahead and graph y is greater than x minus 2. So we're going to go down 2, 1, 2, put a dot. We're going to go up 1 over 1. And that line is dashed all the way up. And I'm going to put in here y is greater than x minus 2. Then I'm going to go to my next inequality that says x is greater than negative 2. And so I'm going to go to negative 2, and I'll have a dashed line here. All right. And this is going to be x is greater than negative 2. That's going to be that one over there. And then finally I have y is less than 3. So I'm going to go up 3 on the y-axis, 1, 2, 3, and draw a solid line. And this is going to be the inequality y is less than or equal to 3. Okay, so I kind of have this region here, right? I have like there's a region there, there's a point there, and then if I actually drew this out right, then there'd be a point down there. So these lines, they keep going, right? Okay, so let's go back to that first one. We want greater than x plus 2. So greater than x plus 2. So where did we end up shading for that one? Yeah, it went away over here. Where did we end up shading for that one? Above it, right? So we want everything that's above this line here. So I'm going to shade that in yellow. So we want everything that's sort of to the above this line, okay? Okay, so I want all that stuff right there. It's kind of nasty, okay? Then I want, next one, x is greater than negative 2. So where am I going to shade for that one? Greater than negative 2. Where's that going to be? To the right or to the left?
To the left.
Greater than negative 2. To the right. So I want everything that's to the right of this line here, right?
Oh my gosh, it's green.
Yeah, crazy, right?
What did you just say? Like, can you repeat
Yeah, I graphed this one. Everything that's greater than to the right, greater than -2. So I'm at my line x is greater than -2. I want to shade to the right. And then finally, I'll use a different color here, and I'll use purple, and we're going to shade that one right there. It says everything below this the line y is less than 3. So I'm going to have all this stuff. So
Oh my gosh.
That's a demented color.
so you should see sort of this black region that's showed up here, right? Which is really, really hard to see right now in that. So instead of that, here's what I have for you, okay? Instead of that, check this out. We can graph all three onto this one. And here's what we would get, okay? So when I bring this out, and I'm going to copy this and bring it into our notes real quick. Okay. Yep, yep. So we'll go there. Boom. So here's the same graph. It's a little bit neater for us. But here's what I want you to notice. Do you notice that we have created this region right here? Whoa. Oh, bummer. Now we're back on track here. So the couple things I want to point out to you is this thing right here, right? This area that's all shaded in here, this part is called a bounded region. And a bounded region is also called a solution region, right? So any point that's highlighted inside that yellow region there, that is from this systems of inequalities, will satisfy all three of these inequalities being true simultaneously at the same time. So that's what's known as a bounded region. And every bounded region is going to have these vertices, right? And the vertices represent all the points where the lines intersect or come together, okay? So each of these is called the vertices. Now, in this particular case, are the vertices guaranteed to be part of the solution region or the bounded region? What do you think, yes or no? Yeah, it depends, right? It depends on whether or not the line crossing is less than or equal to or just equal to. So in this case, the vertices don't in this particular case, right? So what we're learning how to do here is to take these system of inequalities, graph them, and look for a bounded region or a solutions region. So that's where we're going with all this stuff. Does this make sense so far? Yeah. All right, cool. Okay, so my inequality system I have x squared minus y less than or equal to 1. And then negative x plus y less than or equal to 1. So solving for y to graph these, this implies that y is greater than or equal to x squared minus 1. Very good. And this one, solving for y, I would say that y is less than or equal to x plus 1. Right? So one of those is a parabola and one of those is a straight line. So here's what we're going to do. We're going to graph this, find the bounded region, and then identify the vertices. Okay? So if I was going to graph this one, my parabola, down 1 unit. So I'll go down 1 unit, up and over, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, and that would be a solid line. And then this would be a line. I go up, start at 1, and then the slope is up 1 over 1. So I'd have a solid line that would look like this. All right, so I want everything that's greater than the parabola but less than the line. So where would that region be, you guys? Greater than the parabola but less than the line. It would be this little spot right here, right? This little region right inside here. So this little shaded area here, this is called my bounded solutions region. So my bounded region. And the two vertices that I have in this particular case, where the lines intersect, would be right at this point up here, and then right at that point down there. And those points actually are part of the solutions regions because each line was represented as greater than or equal to, in this case, or less than or equal to. All right, so we're going to graph this one in our calculator, show you how to do this. All right, so turn them on to y equals, clear this out. So we'll put both of these in. So we'll do an x squared minus 1. And we're going to go greater than, so I'll go triangle above. And then, oops, I forgot my 1. And then for the next one, we'll go x plus 1. And we're going to go shade below that. So enter 3 times, it looks like. And when it's all said and done, you should see something that looks like this. And there should be a spot where they overlap, right? So you can actually then take your calculator and zoom in and take a look at it and see, look at that. So this area looks a lot like the area that we just graphed right over here. Check those out. Those are pretty, actually, like right on top of each other. Pretty sweet, right? Pretty close. So same thing with this one. I think I have this one for us. Yep. Here we go. So you can see that the same idea represents this one. And that region, of course, is the stuff that's right in between both of those. So what I'd like you to do now in your table groups is graph each of these systems, graph them, and then talk about them and discuss the bounded region or the solution region. So I've gone ahead and graphed these. So hopefully you and your table group saw something that was similar to this when you graphed both of these. Is that true?
Yes.
Okay, so let's talk about number 6. What can we say about number 6 here, these two equations? Anybody come up with anything they talked about in their table groups there?
Parallel lines.
Yeah, we have 2 sets of parallel lines, I agree. But what else about that?
There's no bounded or
Yeah.
region.
Yeah, that's good. There is absolutely no shared region, no bounded region, right? There's this sort of gap in between there. We have points above the red line. We have points below the blue line. But we have no shared or no common points. So in this case, there would be no solution, right, for this one. So that's what it would look like if there was no solution to a system of inequalities. Okay, what about the one on the right, though?
That little.
Yeah, this little sliver in between here, right? This part and then like all of that. But my question is, does it go on forever?
Yes.
Yeah, right? So this goes on forever and ever and ever, and it keeps going up. So this is called an unbounded region.
Oh,
Okay? So if there's an unbounded region, we're talking about an infinite amount of solutions here. So it is possible for you to have a lot of different answers, and these regions don't necessarily have to be bounded. They could be an unbounded region which represent an infinite amount of solutions for this one, okay?
Multi-variable inequalities.
Yeah.
They are.
Uh-huh.
Wow.
Yeah.
Excited for that.
So
wait, so that means
if we have x squared plus y squared is less than or equal to 9, what is that an equation of? That first one, what is that an equation of? Okay, how would we graph this circle, right? We have to say, okay, y is less than or equal to, or y squared is less than or equal to negative x squared plus 9, then take the square root. So y is less than or equal to positive or negative the square root of negative x squared plus 9. We're going to need that in order to plug it into our calculator, because I want us to graph this into our calculator and see. We want less than that. And this one's just a straight up straight line. So let's go ahead and plug this into our calculator and see if we can come up with a bounded region for this one. So to do this one, we're going to go to y equals, we're going to clear everything out.
Plus and minus, so.
Yeah, exactly. So let's do the positive square root. So second square root of negative x squared, and then plus 9. And we want to go less than that. So I'll go calculator 1, calculator, enter 1 twice, give me a upper region, and then 3 times would give me a lower bound. So I would have this. Oh, wait, you can't see that. So let's go zoom 6. There you go. So I only have half a circle right there, right? Where's the other half of the circle?
Plus.
Yeah, the negative of that, right? So
Yeah.
if I want the negative of the square root of negative x squared plus 9, but in this case, right, should I go,
Shade up.
I should shade up. Why should I shade up? Because I'm taking the negative of that, right? So I'm going to go the opposite direction, so I'm going to shade up. So I would see this. And there you'd see my region inside there, right? Now if you hit zoom, you see how do you guys see how the, do you notice how this doesn't look like a circle? This looks like an ellipse?
Yeah.
Because our screen isn't square. So if we go zoom and we actually hit number 5, which is square, it'll look more like a circle, right?
That's so cute.
Then you can actually zoom in and you actually get something that looks like a circle there with everything shaded in. But we also have this other one. We want less than x, right?
Yeah.
So we'll go back to y equals, and we'll go x, and then we'll go lower bound, boom, boom, boom. So there it is. Can you see it? This region right here is the actual region that I'm looking for. Really, really hard to tell on this calculator, but it's a little bit easier to tell on this. So I'll go ahead and shade it. So, oops, I want to change that to less than or equal to.
And then it's less than or equal to 9 up there.
There we go. Less than or equal to? Is that what I have? All right. So there we go. Now this looks a little bit more reliable. So poor Ava has the hiccups and she's distracting everybody. Okay, so where's my solution region or my bounded region, you guys? It's the lower half of the circle. This half's the semicircle here. All right. So this part represents our bounded region.